Greetings to all of you. In today's session, we are going to discuss about intermediate chemistry, which is very important for the entrance exam or any competitive exam if you are preparing on international floor. In the national level, JEE Advanced and JEE Mains for NITs and IIT Engineering entrance stream. In addition to this one, NEET chemistry for medical entrance examination and Telangana, Andhra Pradesh EAMCET exam for engineering entrance examination. In addition to all these, if you are aspiring for any kind of competitive exam, there is a one kind of track will be there, that is general science, where we can find the questions most commonly from this kind of session, right? Let's enter into our today's session. The question number 1 starts with IUPAC protocol. Here, name the following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. As per the IUPAC, what will be the names of these compounds we need to assign? And both are said to be what? Nitriles. If CN is present, the compounds are called nitriles. Then how can we assign name for these compounds? We will discuss, right? So here, whenever this kind of compound where you can find a CH3CN, this carbon which is present in the functional group also accounted in the given root word of alkane, right? So that we have to mention ethane. Eth will be the root word for the given organic chain, because the carbon which present in the nitrile also count in the root word. Fine. And being it is a kind of nitrile, common name is given as alkane nitrile. Its IUPAC name is given as alkane nitrile. 2 carbons, so that let me mention ethane nitrile, right? In the similar manner, if you are ascending 1 carbon here, CH3, CH2, CN will be taken, and being 3 carbon chain, we can mention propane, and its entire name is given as propane nitrile, alkane nitrile, where 3 carbons, so that let me mention propane nitrile. This is the way we can answer the IUPAC nomenclature. There are certain rules and regulations in order to assign name for all the compounds. That's the reason why, first of all, we have to know what is the general terminology. We have to go for individual functional groups. Okay, so nitriles, it will be alkane nitrile. Whatever the carbon chain length, you can go with the alkane, methane, ethane, propane, butane, like that. In that manner, we can increase the number of carbons so that naming will be possible, right? So for the first compound, it will be ethane nitrile. Second compound, it will be propane nitrile for question number 1. Move on to question number 2. See here, explanation part is provided by IUPAC. So if cyano, CN stands for what? Cyano. In general terminology, we can say it is the cyano. The cyano group is present in the given organic compound. So this cyano, as per the IUPAC, can be designated as nitrile, right? So that we can put this nitrile over alkane chain. So completely it is indicated as alkane nitrile. IUPAC name is given as alkane nitrile. As per this protocol, we can write ethane nitrile, propane nitrile for these 2 compounds, right? Move on to question number 2. This question number 2 is collected from Cambridge Assessment International Education, and as per this one, cesium is a radioactive element with a proton number of 55. Any element is said to be radioactive. Radioactive stands for what? Any compound which having the tendency to emit the radiation in terms of alpha rays, beta rays, gamma rays. The compound is said, or the element is said to be radioactive in nature. Fine. So this kind of radioactive elements are more pronounced in case of medicinal chemistry and some other fields as well. That's the reason why this plays a prominent role over here. Cesium is a radioactive element and its proton number is given as 55. This is the statement provided. Let's see what questions we have. Define its proton number. So what is mean by proton number? We have to answer. State 1 industrial use of radioactive isotopes. If radioactive isotopes are present, what applications we can find? At least one isotope, one application we need to provide, right? Let's see what is mean by proton number. Cesium is taken like this, and its atomic number is 55. Atomic number is nothing but number of protons resided in the given element is called its atomic number, right? Number of protons in the nucleus of the atom is called its proton number. The definition is provided. How many protons are there in the given element in the central nucleus as the set of protons, so that it is called its a proton number. For cesium, you can find 55 protons in the central nucleus. 55 set of protons will be there, so that we can say its proton number will be 55. Okay, how many protons are there in the nucleus of the atom is called its proton number. And move on to the question number 2. State one industrial use of radioactive isotope. For that purpose, we have so many. Here, a radioactive isotope americium was taken. It is the F block element, right? A block element, and its atomic mass is provided as 241. Okay, atomic mass 241 is provided. Americium 241 is the radioactive isotope. For this, the application is uniform thickness when rolling steel, paper, determine the location of oil wells. Okay, so you can find multiple applications over there. Uniform thickness when rolling steel and paper. Whenever we are synthesizing steel in the steel industry, steel manufacturing carries in the large machinery, right? So, and moreover, it is the kind of very hard material. In order to get the a uniform thickness in every region, the thickness should remain same in the sheet form or else rod form, whatever the kind it might be. In the constructional purpose, most widely applied one is steel only, no? So in order to make the uniform thickness, the entire rolls of that steel or else a paper industry, even paper thickness should remains the same. If you are getting white paper, you are buying a white paper, or else you are buying a book, what happens? If you see the papers, all the papers are very smooth finished and contains the same extent of thickness. That is applicable by means of this americium 241. So this is the kind of application you can find. And determine the location of oil wells. Okay, so just like water wells, what we can find in the normal region, in some other regions, some particular regions may contain the oil deposits inside the soil. In order to locate them, this americium 241 isotope is very useful. You can detect by means of this isotope where the oil deposition is present in the soil. This is the way we can answer. This is the way we can find the application for americium 241. In addition, sodium 24 will be there. This is also the metal of first main group element. So oil well studies. So if you are finding oil wells, the quantity of oil present and what quality of oil present and what composition we have, entire study is carried by means of this sodium 24. And to locate leaks in the pipelines, whenever any kind of liquids are transporting from one region to another, any leakages are there, you can clearly detect them. And next is about iridium 192. Iridium 192 is the isotope. Iridium is the kind of d block element, no transition metal, we can say. Okay, test integrity of boiler and aircraft parts. Okay, so this isotope iridium 192 can find its applications in the boilers. During the steam generation, boilers can be used, no? So in that you can find its application. Aircraft parts, aircrafts like aeroplanes, jet planes, helicopters, in all those regions also iridium 192 find its applications. And next is about uranium 231. Everybody aware about uranium 235 is the most important isotope used in the nuclear energy generation, a nuclear power plant and naval propulsion system fuel. Okay, so nuclear power plant, in order to generate the electrical current by means of nuclear energy, we can use uranium 235. In addition, naval propulsion system fuel. Okay, so naval propulsion system fuel in the sense, in case of marine navigation, marine transportation, we can use this as a fuel as well. Right, so it can be used as a fuel in the marine transportation, like ships and any submarines, whatever they are moving can be fueled with this kind of uranium 235. Production of fluorescent glassware. Fluorescent glassware in the sense that glassware which can glitter even in the dark itself. It used to what we can say it will be luminous. Fluorescent materials are find luminescence in the darkness. Okay, that kind of fluorescent glassware can be manufactured by using this uranium. Colored wall tiles. Okay, being it is the just now we came to know that fluorescent material, so that it is used in the decoration purpose, like in the constructional way. You can use wall tiles as well. Uranium 235. Fine. So californium 252 will be there. This is another element or isotope found in a block as well, right? Californium 252. Determine moisture content of the soil. Okay, so soil moisture content is most important to determine. Why? Because so soil able to percolate certain amount of water. Certain amount of water can be stored inside the soil, which is called groundwater. How extent of moisture will be there, we can analyze by means of this californium 252. Moisture content is very essential, because if no moisture is there in the soil, what happens? The soil becomes very dry and can be carried away with the wind, so that soil erosion is possible. That's the reason why the most important factor to determine is the moisture content. If moisture is there, that can bind the soil particles, so that that moisture content in the soil is very essential to grow the plants. So in this manner, this californium 252 used to analyze the moisture content present in the soil. Important for the road construction also. During the road constructional purpose, californium 252 can be used. And building industries. Okay, in the industrial purpose, industries are big buildings and big what constructional colonies, we can say, where you can apply this californium 252. These many applications we can find. They're asking for only one, but we found so many. So as data provided, so that we are giving all these. So this is about a cesium radioactive element. Proton number is there, and one industrial application for the radioactive isotopes. They are asking for general radioactive isotopes, so that we mentioned with these many. Right, all these are the part of radioactive in nature. In general, radioactivity stands for what? Any element having natural tendency to release radiation in terms of alpha particles, beta particles, and gamma particles is said to be radioactive in nature, right? For question number 2, we found two different answers here, and move on to question number 3. Question number 3 is collected from what JEE Advanced 2022 question paper. This is the question given from organic chemistry, and these many series of steps are followed over here, and the starting material and final product are provided. We need to assume what kind of reagent suitable and what expected product we have to get in between as an intermediate product. Okay, so starting material is given as a paramethyl nitrobenzene. Whenever paramethyl nitrobenzene was given, P is the reagent to be added, so that Q will be formed. Q will be treated with R further, and S will be formed. S can be treated with either water to give T as the final product, or else S can be treated with U, and you will get final product as the benzoic acid. So that in order to get these many series of reactions, either you can go with the starting material to product, or else a product to starting material to product. That is a natural way of synthesis, we can say. And a product to natural starting material, we can say retrosynthesis, reverse reaction. In either of the way you can go through. There is a kind of options provided. From these options, we can analyze what are the suitable options in order to make all these kind of series of reactions in order to obtain the final product. Okay, so among all the options which is suitable, B, A, B, C will be there. Okay, so let's see what are the possible reactions. Okay, so paramethyl nitrobenzene is taken as the starting material. They only mentioned this starting material. And P will be tin HCl. Tin is the metal. Hydrochloric acid is the acidic condition. Tin HCl is the reagent specific for the conversion of nitro functional group into amino functional group. This simply called what? Reduction. In the presence of metal, nitro is converted into what? Amino functional group, so that here we will get aniline, paramethyl aniline as the Q product. After getting this Q, so we need to treat with another reagent that is also not mentioned, said to be nitrous acid. HNO2 is called a nitrous acid. Whenever amine is treated with nitrous acid, here the formation of diazonium salt. N2 positive is called what? Diazonium salt. NH2 is converted, NH2 is added with one more nitrogen from the reagent, and it will be converted into a diazonium cation. Diazonium ion will be formed. Further, you can treat it with water. Simply nitrogen will be removed, we can say denitrification, and here the formation of OH, which is said to be phenol. Paramethyl phenol will be generated. Simply it is denitrogenation, we can say, by the addition of water, so that we will get OH, which is said to be a phenol, paramethyl phenol. This is the product. What product? T. Product T will be generated. Okay. Here S will be this diazonium. And from this diazonium S product, you may treat with a CaMnO4. Okay, so first of all, you are treating with ethanol. Whenever ethanol is treated, what happens again here the kind of hydrolysis, so that you can remove this one. And CaMnO4 is the reagent, strong oxidizing agent. Wherever methyl is there, that will be converted into what? A carboxylic acid, so that finally we will get benzoic acid as the final product. Okay, in order to get this benzoic acid, first of all, we need to treat with ethyl alcohol. And next is about what? Potassium permanganate, oxidizing agent to be treated, so that methyl will be converted into carboxylic acid. This is the way we can answer these series of reactions. If we know what kind of reagent having what specific activity, so that we can go through this reaction, and finally we will get this product. For question number 3, the suitable reagents P will be tin HCl, Q will be paramethyl aniline, R will be HNO2. That means nitrous acid can be taken. S will be paramethyl benzene diazonium chloride. This S will be paramethyl benzene diazonium chloride. Upon water treatment, paramethyl phenol is the T. And U will be what? One is ethanol, another is potassium permanganate. What we mentioned in this entire series of reactions, this is the way we can answer. This is the actual solution we got here. So let's move on to question number 4. Question number 4 is purely given from physical chemistry, and it is a part of chemical kinetics. Okay, match the rate expressions in the list 1 for the decomposition of X with the corresponding profile provided in the list 2. X and K are constants having appropriate units. Okay, X and K are said to be constants. So by using these rate expressions, we need to deduce what are the suitable graphical representation for that one. Okay, so rate is equal to Kx by K dot plus X, which is taken in the square bracket. Square bracket indicates what? It's a concentration. Fine. Under all possible initial concentrations of X. Okay, all X are said to be initial concentrations were taken. So at that condition, graph will be represented as initial concentration of X taken and the X coordinate, half-life, T half is taken in the Y coordinate, so that Y is equal to mx plus C. Y is equal to mx plus C type of graph will be represented, where intercept is a positive intercept. So you can see from bottom to top, this is inclined in a slanting manner, so that it is the kind of positive slope, right? So this is the way we can answer for first one. Move on to second one. Second one, Kx by X dot plus X will be taken. Here the condition is initial concentration of X is much less than X dot. Okay, so X is less than X dot, they are saying. And one thing we need to remember, that in the denominator it is there, moreover it is less than this one, so that we can exclude that. We can exclude this term of X taken in the square bracket, so that the answer will be Q, where you can see half-life and initial concentration when taken, it is independent on the initial concentration and the line is horizontal. Okay, a axial line or linear line, you can clearly notice, because what they are saying in this, concentration of X is much less than X dot. Okay, so X is present in the denominator, so that its value will be diminished, first thing. And the second is, with respect to X dot, its value is still less, they are saying, so that its value is almost infinitesimal, so that it will not depend upon the initial concentration, so that independent initial concentration of half-life is represented in this graph. Straight line will, you can notice. And next is about rate is equal to kx by x dot plus x, where condition is initial concentration of x are much higher than x dot. It is reversed to the second condition. Second condition much less, third condition much higher. At that case, the graph will be represented as y is equal to mx minus c. Negative slope we can notice, intercept with the negative slope you can notice, and here concentration of x taken on the y-axis, time is taken on the x-axis, and the value will be inclined towards the bottom, top to bottom. This is called what? Y is equal to mx minus c, negative slope you can clearly notice over here. And one more, rate is equal to k into x to the power 2, right? X to the power 2, and where initial concentration of x is much higher than x dot. Initial concentration in both the cases, initial concentration is much higher only, so that almost a graph remains the same. But only the difference is here x taken as the square. X taken as the square means what? X concentration is doubled in the numerator. That's the reason why the graph is somewhat different when compared to the S. So it will be represented as a T. Okay, conditions remain same, so that graph also remains identical, but only the difference is here concentration of x in the numerator taken as a square value, so that it will be taken as a almost a similar term. So this is the way chemical kinetics question will be answered, where rate of the reaction versus its graphical representation is mentioned. Sometimes they are mentioning half-life, sometimes they are saying about rate of the reaction, sometimes they are saying about concentration of x, a log of concentration of x. Okay, this is the way we can answer the question number 4. Move on to question number 5. It is collected from the Gurukulam Degree College Lecturer Entrance Examination. Identify the correct order of orbitals, increasing order of their energy in the crystal field splitting diagram of distorted octahedral. Distorted octahedral is said to be what? Tetragonal complex. Why distorted octahedral complex will be generated? Due to the John Teller distortion. Fine. So that is the case, and this is the question collected from inorganic chemistry. Moreover, we can say it is the coordination chemistry, because it is the part of what? Octahedral complex, no? And we have to identify what? Increasing order of energy of the orbitals in the crystal field splitting. Crystal field theory is there. In order to explain about the coordination complexes, so many theories, so many scientists framed so many theories. So here crystal field theory is one of the theory, somewhat advanced. We can say it used to explain about the coordination complexes. What will be the right order of the orbitals we need to assign? For that purpose, here free atom if present with 10 electrons, for example, free atom having 10 electrons. So if octahedral is there, octahedral splitting is there, what happens? T2g orbitals laying at the bottom, Eg orbitals are laying at the top. This is the way clearly depicted. This is the way we can clearly make a partition among them, right? 6 electrons will reside in the T2g orbitals, and Eg orbitals will be accompanied by 4 electrons, means 2 orbitals will be there. T2g are 3 orbitals, Eg will be 2 orbitals. But what they are saying about a distorted octahedral called a tetragonal. In case of tetragonal, here this is the way you can notice. Only this part you have to focus. This part is the tetragonal geometry, where the orbitals laying at the bottom will be dxy, means least energy orbitals will lay at the bottom. Dxy, can we see dxy anywhere? Only in the option number Y. dxy will be there. Dxy, dyz, dzx, all these orbitals are degenerated. Okay, so that we can say dxy, dzx, dyz, all these in tetragonal geometry, you can clearly notice these orbitals are present. Okay, so dx square minus y square will not be there. And highest energy orbital will be dx square minus y square. If you see, dx square minus y square orbital will be the highest energy. Next is about what? Dz square. Dz square orbital is having next level energy. So if you see, dx square minus y square is equal to dz square, they are saying this is wrong. dxz dyz, this is wrong. Dz square is higher, this is wrong. Only the possibility is dx square minus y square is higher, and the next level will be dz square, and the next whatever the kind xz dyz they are saying, that means both are degenerated, equal energy. And next dxy will be there, that is clearly represented over here. This part we have to take into the consideration. Dx square minus y square is higher energy, dz square of next level, yz, zx, xy will be there. This is the way we can answer. For question number 5, option number 1 will be the correct answer. Move on to question number 6. Question number 6, which of the following complex is more stable? This is the question given from what? We can say coordination chemistry only, and these are the metals belongs to coordination compounds related with what? D block elements, and these are the complexes which are formed by second main group elements, and all are given as a monohydroxides, but second main group elements having natural tendency of bidentate, means their valency will be 2. They able to bind with two different functional groups. That's the reason why all these are given with their positive charge. Okay, beryllium hydroxy cation, magnesium hydroxy cation, calcium hydroxy cation, barium hydroxy cation. These many are provided. Among all, which is more stable, we need to assign. In order to assign its stability, let's go with the explanation part. Okay, so from this data, it is very clear that all the metal hydroxide complex cations we can say, because being they mentioned in the square bracket, let me mention complex, and all are assigned with the positive, so that complex cation, right? All metal hydroxide complex cations belongs to what? Second main group elements, beryllium, magnesium, calcium, barium. This is a increasing order in the group. Top to bottom, we are increasing, we are moving to the higher atomic number. This is the way we can allocate. Okay, as we are descending, the size of metal increases. When compared to beryllium, magnesium is larger, magnesium to calcium is larger, calcium to barium is larger. That is a point number 2. According to the Poisson rules, requirement of the stable complex, in order to form the stable one, stable complex, the requirements are so many are there. I am considering only these many. Small cation is favorable. Okay, small cation is favorable. As we are descending, size of metal increases. All are monopositive only, no? So that this charge will not affect their size. Okay, all are monopositive cations only, so that we can say top to bottom size gradually increases. But a stable complex requirement is a smaller cation. Among all smaller cation is beryllium. That's why stability for beryllium hydroxide will be larger. So this is the way we can answer this. Question number 6. Which of the following complex is more stable? Beryllium hydroxy cation is more stable, right? By this, we completed the entire session. And I hope I explained everything in a very well manner. If anything is required, you can comment over here. And this is the way we also collected the data, statistical data related with their atomic sizes. If beryllium is taken into the consideration, 0.31 is the size of that. Magnesium is of 0.65. Calcium cation, calcium plus 2 cation is having 0.99. Strontium plus 2 is having 1.13. As you observe, top to bottom size gradually increases. Smallest one is beryllium. It's very obvious that smallest cation is favorable for the stable complex. Hence, we can clearly assign beryllium hydroxide is more stable, right? So by this, we entire 6 questions in the detailed explanation is provided with you, and I am requesting you to like the channel, if you're interested about this one, and comment which part is really important or else really interested for you, and share with us parents who are seriously preparing for the examinations of the same kind what we are explaining here, and subscribe the channel in order to receive more such kind of updates in the near future. Thank you one and all for your patient listening. Thank you.